guys, this is Chapter 3, Linear Functions, Lesson 3.6, Proportional and Non-Proportional Relationships. In this lesson, we're going to use a lot of big words, but we're really talking about two related, very simple ideas that you've already really explored. So let me explain. When we talked about direct variations, we were talking about proportional relationships. When we had y equals kx and we solved for k, we got y over x. That's a proportion or a ratio that's constant. And we didn't have anything like plus 2 on the end of that, or minus 5 or anything like that, because our graph passed through 0 and 0, the origin. So all of our graphs looked in some way like this. They either went up or down, but they went through the very center of the graph, the origin. So other linear relationships are non-proportional because they cross the y-axis somewhere other than the origin. They have a y-intercept other than 0. And so we saw some of these arithmetic sequences that don't start with 0, and we put those into equations, so we might be able to use that formula a little bit. But basically what we have to explore is, what would y be when x equals 0? The reason we need to know that is it's going to change our equation a little bit. So if you look at page 197, it says key concept, proportional relationship, and you can see a graph there with a table with an equation that says y equals 3x and a table that has x0 and y0, and then x1 and y3 and x2 and y6. And you can see that we're going plus 3, plus 3, plus 3, but we also go through the origin, and you can look at that graph right there in the picture and see that that is a direct variation. That is a proportional relationship. Other equations, let's just jump through to some of the problems. Look on page 200, and you'll see in example 2 that line does not go through the origin. So it looks something like this. And if you count down 1, 2, 3, 4, 5. 1, 2, 3. Didn't quite make my line long enough. 1, 2, 3, 4, 5. Then you can see that that line crosses down here. And then for the sake of my graphing this nicely, 1, 2, 3, 4, 5, it also crosses 1, 2, 3, 4, 5, up here. And let me see if I can draw a line through those two places. And so we have a line that looks something like that. We have a y-intercept down here at 0 and -5. We have an x-intercept there that is not going to affect our equation. But what we're going to have, instead of y equals kx, we are going to have a number here. It's the same as slope. We're going to figure that out. But we're also going to adjust this. We're going to have a -5. So that just tells us that the graph crosses the y-axis at -5 down here. Let's figure out what the slope of this equation would be. So every time I'm going over, let me get a little color here. Every time I go over 1, I'm going to move up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. So I could say that my rise over run, or my slope, my m or my k, is going to be 1. So we could write an equation, y equals 1x, or we could just write x, -5. If you look at number 3, What we have here is a graph that crosses a little higher. 1, 2, 3. Crosses up here, and then 1, 2, 3. Crosses here, and we actually have a line that looks something like this. And so we would say that the y-intercept here is at 0 and positive 3. And so when we write our equation y equals kx, we're actually going to adjust this and put a plus 3 because you just are going to write whatever the y-intercept is right here. So we need to know what the slope is for this line. We go over 1 and we go down 1, over 1, down 1, over 1, down 1. So my rise over run in this case, I am not going up, I'm actually going down, so I'm going to use a negative, and it's going to be negative 1. So I can write this equation y equals negative 1x, or negative x plus 3. So that's an equation for that line. So what we're seeing here is that equations have two important things other than the x and the y that are always there. They have a number right here that is the slope, and it's always attached to the x. And then they have a number right here that is the y-intercept. And if it's a negative, then that'll change to a minus. Let's look at number 4. We have a little table of values here. We have 1 and 35, 2 and 70, 3 and 105, 4 and 140, 5 and 175, and we don't know what it would be if it was 0, so let's think about that. We're going up by plus 1, plus 1, plus 1 here. So that's fine. And here we're going up by plus 35. Remember in the last lesson I told you we go subtract going backwards. So we would do 105 minus 70, which would be 35. We would do 140 minus 105, which would be 35. And like that. So we're going plus 35 every time. So one way of just seeing this from the table is we could just go backwards 35 here and see that we're at 0. So we know that this particular equation is going to go through the origin at 0 and 0. So it's a direct variation. It's going to be y equals kx. There is no plus anything here. It would be plus 0, right? Because 0 is the y-intercept. So we just need a slope. Well, we already found out the slope. Remember, slope is the same as d. It's our common difference. And so we can just write this equation, y equals 35x. And we could use this equation. It says in letter C there, it says find the number of pages read if 8 comic books were read. So we didn't talk about the fact that this was books read and pages read. But if we read 8 comic books, how many pages would that give us? We're just going to plug in y equals 35 times 8. Okay, in number 7, we're not going through the origin, so we're going to need an extra number to stick on the side. I can see that it crosses at -2, so I'm going to have f of x, or y, equals something times x minus 2. So the minus 2 is just that y-intercept there. So I'm kind of looking to see if I can figure out a nice place to look at this. Okay, way up where that other dot is, I notice that I have to go up 1, 2, 3, 4, 5, 6, and then run 2. So if I have a rise 6 and run 2, I'm going to have a slope of 3. Determine the related function, and then determine if the function is proportional or non-proportional. So here when we have 0, 3, 6, ... we're starting at 0, and 3 minus 0 is 3, 6 minus 3 is 3. So we're going plus 3, and we're starting at 0. So we can just say y equals 3x. Those are beautiful and simple. Number 10, it looks like since we're starting on -4 that perhaps this is not proportional. We'll call this proportional. It is also called a direct variation. So I want you to just keep, we're using lots of words, but we're not actually using different ideas. We're just giving more words to the same ideas. Okay, so if I'm looking, I'm going to subtract going backwards. 4 minus 0 is 4. 0 minus a -4 is 4. So I know I'm going plus 4, plus 4, plus 4, but look, I'm starting at -4. So this is actually incredibly simple. We're going to say y equals 4x minus 4 because this is our starting place. The cool thing is this makes a really simple graph that we can easily think about. 1, 2, 3, 4. I barely gave myself enough room here, but this is where it starts. We rise 4, run 1. 1, 2, 3, 4, run 1. And so I have this line that looks something like this. I should have drawn the other one. I should have drawn the other point to make it a little more accurate because now it's a little wonky. Whoa. Okay. Never mind. There we go. That'll have to be good enough for now. All right. So what did we learn today? We have two kinds of equations, two kinds of linear equations. We have y equals kx. These are direct variations. They are proportional. And they go through the origin, which is 0 and 0. So they go through the very middle of the graph. They're very simple, okay? And then we have this one, y equals, well, we could say kx, and then we have plus or minus something. All right, let's go ahead and put this in the form that we will be talking about. Y equals mx plus b. This is slope-intercept form. We haven't talked about that yet. I've been trying to do it in the order the book introduces it. But this is k. M is the same thing as k, and it's just slope, and it's rise over run. It just talks about the steepness of the graph, right? That's the m part of it there. And then we have b, which happens to be the y-intercept. The graph does not go through 0 and 0. Where does it cross? Where does our line cross the y-axis? Okay, so two kinds of equations. Proportional ones, they go through the origin. Something like that. Doesn't have to be a positive slope, can be negative. And then we have non-proportional ones. And they have a little extra piece to the equation, which just tells us where we crossed. Okay. Where we crossed the y-axis. So we still have slope. They all have slope. They always have slope. That's a direct variation, but then we might have plus something there, like plus 3 or plus 2, or maybe it's minus if we cross down a little bit lower, like maybe down here. Then we might have y equals some number for slope plus times x minus maybe 2 or something like that. All right, work some problems in Alex, and we will be doing some review because this is the end of chapter 3.